They were built when trucks were simple, heavy, and made to survive anything. No computers, no complicated electronics, just massive engines and engineering designed to last forever. These are 10 European trucks from the 1950s that refused to die. Number 10. The Volvo L395 Titan. Sweden, 1954. Volvo looks at the trucks available in post-war Europe and decides none of them are good enough for what the Scandinavian landscape demands. The result is the L395 Titan, and the name is not modesty. The Titan was built around Volvo's D96 diesel engine, a direct-injection six-cylinder that produced around 150 horsepower at a time when that figure commanded serious respect. But the horsepower number tells only part of the story. What mattered was the torque curve, broad, flat, and available at the low RPM that loaded trucks spend most of their working lives in. The Titan didn't need to be wound out to pull. It pulled from the moment you touched the throttle, and it kept pulling on the grades that destroyed lesser equipment. Volvo engineered the Titan with the understanding that a truck operating in Scandinavia would face conditions that no southern European machine was designed for. Sustained climbs in freezing temperatures, roads that were partially unpaved, loads that pushed the legal limits because the economics of the timber and mining industries demanded it. Every component was sized for the worst case rather than the average case, which is why Titans that spent their first lives hauling timber in Sweden spent their second lives doing the same thing in South America, and their third lives being restored by collectors who discovered that the mechanicals were still fundamentally sound after 50 years of hard use. No computer has ever shut down a Titan. There are no computers to shut it down. Number 9. The Mercedes-Benz LP 333. In 1955, Mercedes-Benz introduced a truck that embodied a philosophy the Stuttgart engineers called Überdauern, outlasting. The LP 333 was a forward-control heavy hauler built around Mercedes' OM 315 diesel engine, a six-cylinder unit that mechanics across 3 continents would come to know as one of the most forgiving pieces of machinery ever built. The OM 315 could run on poor quality fuel. It could tolerate maintenance intervals that would destroy a modern engine. It could be rebuilt with basic tools in environments where sophisticated workshop equipment did not exist. These were not accidents of design. Mercedes engineers in the early 1950s understood that a truck sold into European markets would eventually make its way to markets where the infrastructure supporting it was minimal, and they built accordingly. The LP 333 became the backbone of Middle Eastern and North African transport through the 1960s and 1970s precisely because it refused to stop working when every reason to stop existed. Operators in those markets did not choose Mercedes because of the badge. They chose it because a Mercedes from the 1950s would still be running when everything else had been cannibalized for parts. Many still are. The OM 315 engine is not complicated enough to fail catastrophically. It wears slowly, announces its wear honestly, and accepts repair without complaint. That is not a design philosophy you find in a modern emissions-compliant engine with 17 sensors monitoring its every function. Number 8. The Fiat 682. Turin, 1952. Fiat introduces a heavy truck that will go on to define Italian commercial transport for 2 decades and African heavy haulage for considerably longer. The 682 was powered by Fiat's own 6-cylinder diesel, initially producing around 130 horsepower and later developed to higher outputs as the model evolved. What made the 682 exceptional was not its power output but its engineering margin. Fiat built the 682 with structural reserves that operators consistently exploited, running loads beyond the rated capacity, on roads below the rated quality, for hours beyond any reasonable duty cycle, and the truck accommodated all of it without the kind of catastrophic failure that exploiting modern trucks' limits produces. The 682's reputation in East Africa is the clearest testimony to what Fiat built. Trucks that arrived on the continent in the 1960s as commercial vehicles became the workhorses of construction projects, mining operations, and agricultural transport that had no access to dealer service networks or computerized diagnostics. The mechanics who kept them running did so with hand tools, improvised parts, and the specific advantage that every system on the 682 was understandable by a skilled human being without electronic assistance. Some of those trucks are still running. Not restored, running. The distinction matters enormously because a restored truck is a monument to what was. A running truck is proof that what was built then is still adequate now. Number 7. The Büssing 8000. Brunswick, Germany. 1950. A company with roots in the 19th century produces a truck that carries one of the most unusual engineering choices in European commercial vehicle history: an underfloor engine. Büssing positioned the 8000 six-cylinder diesel beneath the cab floor rather than in a conventional nose-forward position. The reasoning was strictly practical. An underfloor engine meant a flat cab floor, which meant easier entry and exit for drivers who spent their working lives climbing in and out of the cab dozens of times per day. It meant better weight distribution over the front axle. It meant a lower center of gravity that improved stability under load on the mountain routes that German and Austrian operators ran. It also meant a maintenance challenge that Büssing solved by making the engine extraordinarily accessible from beneath the vehicle and by building it to require less frequent attention in the first place. The 8000's engine was not the most powerful option available in 1950. It was the most durable option available, engineered to run at sustained loads without the thermal stress that pushed competitors' engines toward premature wear. Büssing was absorbed into MAN in 1971, ending one of the oldest names in German commercial vehicles. The trucks did not end with the company. The 8000 series had been built in sufficient numbers and to sufficient quality that examples continued working through the 1980s and beyond, and the underfloor engine configuration that Büssing pioneered influenced European bus and coach design for decades after the last truck left the factory. Number 6. The Leyland Octopus. Lancashire, England. 1946, with the design carrying through the 1950s in continuous production. Leyland Motors builds an 8-wheeler that becomes the defining heavy truck of post-war British industry and earns a name that describes exactly what it is. 8 wheels, 4 axles, the Octopus configuration gave British operators something that the weight distribution regulations of the era demanded: the ability to carry maximum legal loads without concentrating that weight on too few contact points. Leyland's engineering team understood that the regulations were not going to change and built a truck that worked within them completely rather than testing their limits. The power came from Leyland's own 0.600 diesel engine, a 6-cylinder unit that the company had developed from pre-war experience and refined through wartime truck production for the Allied forces. The 0.600 was not a sophisticated engine. It was a durable engine, which in the context of a working truck is the more important quality. Operators could predict rebuild intervals in miles rather than guessing based on symptoms, because the 0.600 wore predictably and communicated its wear honestly through oil consumption and power output rather than sensor warnings and fault codes. The Octopus hauled steel from Sheffield mills, coal from Yorkshire collieries, and cement from works across the Midlands through the 1950s and into the 1960s. Examples that survived into the 1980s, having outlasted their intended service lives by decades, were still finding work in specialist heavy haulage applications where their 8-wheel stability and mechanical simplicity outweighed any disadvantage their age created. Preserved examples today are not just cosmetically restored, they are mechanically restored, which means they run, which means Leyland built something in Lancashire in the late 1940s that is still fundamentally capable of doing what it was built to do. The company that built it no longer exists in any recognizable form. The Octopus does not appear to have received that message. Number 5. The Scania-Vabis L75. Södertälje, Sweden, 1958. Two companies, Scania and Vabis, had merged in 1911 and spent the following decades building trucks that Scandinavian operators trusted with everything that mattered. By the late 1950s, the L75 represented the peak of what that combined engineering heritage could produce. The L75 ran Scania-Vabis' own DS10 diesel engine, a 10-liter 6-cylinder that delivered its power with the mechanical authority that Swedish operators demanded for the timber routes of the north and the coastal freight runs of the south. What distinguished the DS10 was not peak output, but sustained output. The ability to deliver its rated power continuously over hours of hard work without the thermal degradation that shortchanged other engines at the end of a long shift. Scania-Vabis built the L75 on the understanding that a truck in Nordic service would spend significant time operating at or near full load in temperatures that tested every seal, every gasket, and every bearing in the drivetrain. The engineering response was to overspecify every component by a margin that felt excessive until the truck was 50 years old and still working, at which point the margin revealed itself as foresight. The L75 established design and engineering principles that Scania, the name that survived the corporate evolution, carried forward through decades of subsequent development. Modern Scania trucks bear the family resemblance not just in the badge but in the engineering philosophy, which is a rarer form of inheritance than badge continuity alone. The L75 did not just survive, it taught. Number 4. The MAN 750L1. Munich, Germany, 1951. MAN, Maschinenfabrik, Augsburg-Nürnberg, brings to market a heavy truck that embodies German engineering discipline at its most concentrated. The 750L1 is not a truck that makes dramatic promises. It is a truck that delivers consistent performance, without drama, which is a more difficult engineering achievement than it sounds. The engine was MAN's own DO846 diesel, a 6-cylinder unit built to the exacting tolerances that German manufacturing culture demanded. Where other manufacturers of the era built to tolerances that allowed the engine to run adequately, MAN built to tolerances that allowed the engine to run correctly for an extended period before wear brought it to the adequate range. The practical difference, measured in service life, was significant. The 750L1 became a fixture in German construction kits. MAN trucks from this era became the standard against which other equipment was measured, and was a commercial advantage that outweighed every other consideration. MAN continued building trucks, eventually becoming part of the Volkswagen Group, and later merging with Scania under the Traton umbrella. The engineering culture that produced the 750L1 persists in the company's current products, which is the most honest form of legacy an industrial manufacturer can claim, not a museum exhibit, but a living influence. Number 3. The DAF A50. Eindhoven, Netherlands, 1950. Hub and Wim van Doorn, two brothers who had started by building trailers in their father's blacksmith shop, introduced the A50 heavy truck and established the pattern that Dutch commercial vehicle engineering would follow for the next 3 decades. The A50 was powered by a Hercules diesel engine, a British unit that DAF specified because it offered the combination of output and reliability that the Van Doorn brothers demanded. DAF at this stage was not yet manufacturing its own engines. That came later, but the selection of the Hercules reflected an engineering judgment that the Van Doorn brothers applied to every component decision throughout the truck's development. Use the best available. Build the structure around it to last longer than the component itself. The A50's cab was simple to the point of austerity. There were no features that served comfort at the expense of durability. Every material choice prioritized longevity over refinement, which is why A50 cabs that have spent 50 years in northern European weather are often structurally sound in ways that later trucks with more sophisticated materials are not. DAF grew into one of Europe's significant truck manufacturers before being acquired by PACCAR, the same American company that owns Kenworth and Peterbilt. In 1996, the Eindhoven factory still builds trucks under the DAF name, and the Van Doorn brothers' insistence on building things properly rather than building things cheaply can be traced in an unbroken line from the A50 to the current production floor. The A50 itself earned something that no marketing campaign can manufacture. It earned it mile by mile, load by load, in the specific and unglamorous way that working trucks accumulate reputations. Operators who ran them trusted them. Mechanics who maintained them respected them. And the ones that survive today justify both responses completely. Number 2. The Magirus-Deutz 120 series. Ulm, Germany, 1951. Magirus-Deutz introduces a truck with an engine unlike anything else available in European commercial vehicles, an air-cooled diesel that needs no radiator, no coolant, no water pump, and no cooling system component capable of failing at the worst possible moment. The Deutz air-cooled engine was the product of decades of development by Klöckner-Humboldt-Deutz, and its application in the Magirus truck range created a vehicle that operated in conditions where water-cooled engines could not be trusted. Desert heat, Arctic cold, high altitudes where coolant boiled before the engine reached operating temperature. The air-cooled Deutz diesel ignored all of these conditions because it had no cooling system to compromise. The practical consequences of this design choice were felt most clearly in export markets. Magirus-Deutz trucks became the vehicle of choice for United Nations relief operations. for mining companies working in remote locations, and for military logistics operations in environments where maintaining a conventional cooling system was impractical. The trucks went where other trucks could not go, not because they were more powerful, but because they were more reliable in conditions that exposed conventional trucks' single greatest vulnerability. The air-cooled engine had one significant disadvantage. It was loud, noticeably, persistently, unmistakably loud. A mechanical clatter that announced a Magirus-Deutz from a considerable distance, and that operators either learned to ignore or never forgot. But operators who had watched a water-cooled engine destroy itself on a desert road because a hose failed or a thermostat stuck found that the noise was a reasonable price for an engine that kept running regardless of ambient temperature. Magirus-Deutz eventually merged into Iveco in 1975, and air-cooled truck engines became increasingly uncommon as cooling system reliability improved. But examples of the 120 series trucks survive in working condition on 3 continents, a geographic distribution that reflects the export success of a design that solved a specific problem better than any alternative available at the time. Number 1. The Lancia Esatau. Turin, Italy, 1950. Lancia, a company better known today for passenger cars and rally racing than for heavy trucks, produces a vehicle that will go on to be considered by many Italian transport historians as the finest truck ever built on Italian soil. The Esatau. The name comes from the Italian for 6 and the letter T, a reference to the 6-cylinder engine configuration that Lancia specified for the truck's heaviest variants. But the name undersells what Lancia actually built. The Esatau was not simply an engine in a frame. It was an integrated engineering achievement in which every system had been developed to work with every other system rather than being sourced separately and assembled into a package. Lancia built the Esatau's engine in-house, the 6-cylinder diesel producing output that was competitive with the best European alternatives of the early 1950s. The transmission was Lancia's own, matched specifically to the engine's torque curve rather than being a general-purpose unit adapted from another application. The suspension was developed for the specific load cases that Italian operators faced: the mountain roads of the Alps and Apennines, the agricultural plains of the Po Valley, the industrial freight of the northern cities. The result was a truck that drove with a coherence and balance that contemporary drivers noticed immediately, and that owners who have restored examples describe today in terms that sound more like car reviews than truck evaluations. It responded to inputs with a directness that heavier, less precisely engineered trucks did not match. It held its settings over distance in a way that suggested every component had been designed with every other component in mind. Lancia exited the truck market in 1969, absorbed into Fiat's commercial vehicle operations. The decision ended one of the most distinctive engineering programs in European trucking and produced exactly the kind of loss that defines your channel. A product so good at what it did that its disappearance left a gap that nobody quite filled in the same way. The Esatau's survivors are cherished not because they are rare, though they are cherished because driving one makes immediately clear what was lost when Lancia stopped building trucks. The engineering coherence that distinguished the Esatau from its contemporaries was not transferable to a parts bin. It lived in the specific combination of components that Lancia developed together, and when the program ended, that combination ended with it. No sensor failure will ever strand an Esatau on a mountain road. No emissions regeneration cycle will ever interrupt its work. No software update will ever change its behavior. It does what it does, as it was built to do it, with the mechanical certainty of a machine that was designed by people who understood that a truck's only obligation is to work when it is needed, and to keep working long after the reasons to stop have accumulated past counting. That is what the 1950s built. Nobody has built it quite the same way since.